In this video, I'm going to talk about link aggregation concepts, configuring Etherchannel on Cisco switches and routers. First, you might ask, what is link aggregation? The term link aggregation is used to describe the assorted methods of combining or aggregating multiple network connections in parallel or bundling them together in order to increase bandwidth or throughput beyond what a single connection could provide, as well as providing redundancy in the event that one of the physical links should fail. Not only is it possible to combine a number of physical links between switches to increase the overall speed of switch-to-switch communication, but oftentimes it's a necessity. However, the built-in mechanism of spanning tree protocol will block redundant links to prevent routing loops. Etherchannel groups multiple physical ports into one or more logical Etherchannel links known as port channels. Link aggregation facts: Etherchannels can be formed by using PAgP or LACP protocols or just turned on. Port aggregation protocol is read as PAgP. It's a Cisco proprietary protocol. Link aggregation control protocol is a multi-vendor environment. Most configuration tasks can be done on the Etherchannel interface instead of on each individual port. Etherchannel relies on existing switch ports. It creates an aggregation that is seen as one logical link, therefore a spanning tree won't block it. Load balancing takes place between links that are part of the same Etherchannel. Etherchannel provides redundancy because the overall link is seen as one logical connection, but if one physical interface fails, the remaining interfaces load balance the traffic. Restrictions for Etherchannel: configuration settings must match on both switches. Interface types cannot be mixed. Fast Ethernet and Gigabit Ethernet cannot be grouped together. They must be the same speed and duplex mode, providing full duplex bandwidth of up to 800 megabits for Fast Etherchannel or 8 gigabits for Gigabit Etherchannel. Cisco IOS switch can support 6 Etherchannels. It's created between two switches or a server and a switch or a router and a switch. If one side is configured as a trunk, the other side must be a trunk within the same native VLAN. All interfaces in the bundle must be assigned to the same VLAN. Each Etherchannel has a logical port channel interface, and changes to a channel affect its physical interfaces. So if the port gets shut down, all interfaces get shut down. Port aggregation protocol. As stated before, PAgP is Cisco proprietary. It helps create the Etherchannel link by detecting the configuration of each side and ensuring that the links are compatible so that the Etherchannel link can be enabled when needed. The on mode: this forces the interface to channel without PAgP or even LACP. Interfaces configured in the on mode do not exchange PAgP packets. PAgP desirable: this mode places the interface in an active negotiating state in which the interface initiates negotiation with other interfaces by sending out PAgP packets. PAgP auto is basically in a passive mode, and it waits for a PAgP packet that gets sent, and it says, okay, I'll form a PAgP link with you. The modes must be compatible on each side. If one side is configured to be in auto mode, it is placed in a passive state, waiting for the other side to initiate the Etherchannel negotiation. If the other side is also set to auto, the negotiation never starts and the Etherchannel does not form. If all modes are disabled by using the no command, as in no passive, no desirable, no auto, there is no mode configured, then the Etherchannel is disabled. The on mode manually places the interface in an Etherchannel without any type of negotiation. It only works if the other side is also set to on. If the other side is set to negotiate parameters through PAgP, no Etherchannel forms because that side is set to the on mode. It does not negotiate. No negotiation between two switches means that there's no checking to make sure that all the links in the Etherchannel are terminating on the other side and that there's PAgP compatibility on the other switch. LACP, Link Aggregation Control Protocol. It provides the same negotiation benefits as PAgP to create the Etherchannel, and the requirements of the interfaces on both sides are still the same. Modes are as follows: on, This mode forces the interface to channel without LACP. If interface is configured in the on mode, do not exchange LACP packets. LACP active, this mode places the port in an active negotiation state, just about like desirable in PAgP. In this state, the port initiates negotiations with the other ports by sending LACP packets. LACP passive, this mode places the port in a passive negotiating state, almost like the auto mode in PAgP. In this state, the port responds to LACP packets that it receives, but does not initiate the LACP packet negotiation. Just as with PAgP, the modes must be compatible on both sides for the Etherchannel link to form. The on mode is repeated because it creates the Etherchannel configuration unconditionally without the use of PAgP or LACP dynamic negotiation. The following steps create an Etherchannel. A configuration demonstration follows, creating 3 Etherchannels using the modes of LACP, PAgP, and ON, as well as the configuration of a trunking for each. Step 1. Specify the interfaces that compose the Etherchannel group by using the interface range command. Create the port channel interface using the channel group command with the mode active or passive for LACP, desirable or auto for PAgP, or just on. A channel group number needs to be selected, and it must be the same in both ends of the link. Change the layer 2 settings in a port channel interface configuration mode using the interface port channel command. This is where you would say port channel 1, 2, 3, 4, 5, whatever, and you would change it to switch port mode trunk. For this segment, I'm using a copy of Cisco's packet tracer to represent 4 switches that are going to be hooked together. I've got 4 channels connecting switch 1 to switch 2 that are going to be configured using PAgP for Etherchannel. 4 channels between switch 2 and switch 3, which will be using LACP, and then 2 channels between switch 3 and switch 4 that are just going to be channel mode on. Pause while I bring up a switch. Alright, we're going to go config T, get into global configuration mode, and then we're going to interface the range of channels that we're going to configure, which are fast Ethernet 0, 1 through 4. You want to make sure you shut those channels down. Therefore, there's no quibbling from the switch about any of the configuration. Now, some people call it an unnecessary step, but I like to do the channel protocol and specify what the channel protocol is. You get 2 choices, LACP or PAgP. This one here, like I said, is going to be PAgP. So we set the channel protocol, and then we go and do channel group. The channel group number, which you can have up to 6 port channels on each switch. Channel group number 1, then you set the mode, and then what type of mode is it? You've got active for LACP, unconditionally, auto for PAgP, this is the passive mode of PAgP, desirable for PAgP, on, and passive. And we're going to make this one desirable because we're going to turn on PAgP in the non-negotiate mode. It's going to be actively seeking to make it. So it creates port channel 1. Alright, and then we do no shut on these terminals to bring them back up. They're going to stay down because there's no connectivity on the other end. So now we also go back and we go interface port channel 1. And we want to tell it switch port mode trunk, because we're going to make it as a trunk. And once again, just for good measure, we're going to go no shut, so it should be fine. We'll come back to it in a moment. Jumping over to switch 2, I'm already in the global configuration mode. So now we're going to complete our channel group for going back to switch 1. So we're going to interface the range. This time we're going to go auto, which it will automatically negotiate with the PAgP desirable on the other end. And we're going to go no shut. And you're going to see automatically that the Ethernet channels came up in a group and port channel 1 came up as it is. So let's do a quick show Etherchannel summary. And we're going to see that port channel 1 is up. Shows that the status is connected. The ports are listed up in P as in passing traffic right there, port channel. A D would be down. The S is meaning is layer 2, and U is in use. Now we're going to do the next range, which is going LACP over to switch 3. So I'm going to interface the range F0/5 through 8. Oop, better back that up. And we're going to go channel group. To mode active. This makes it LACP no matter what. I didn't have to go channel protocol, even though I do prefer to do it that way, but this makes it LACP automatically. We go no shut. It's sitting there waiting on us to go to switch 3. So now I'm going to go over to switch 3 and configure those channels. Alright, interface range F0/5 /8. And this time we're going to go passive, which is LACP in the accepting negotiation mode. Notice that the port channel has come up. Port channel 2 says it's up. We also want to go switch port mode trunk. Do show Etherchannel summary. We add the word do because we're in the global config prompt. And it's going to tell you right there, hey, port channel 2 LACP is up. Now we're going to interface the range G0/1 space 2. And we're just going to go channel group 3 mode on. No shut. And it's going to come up and it's going to wait on the other side. Pause this while I go over to switch 4. Okay, we're going to interface the range of gig 0, 1 through 2. And we're going to go in there and go channel group 3 mode on. No shut. And switchport mode trunk. Now we go do show Etherchannel summary. And we're going to see that right there it says port channel 3. There is no protocol. Gig 01 and gig 02 are up and in the port channel. Jump back over here to switch 3, do another show Etherchannel summary, and now we see two of them. We have the LACP, which is the one going over to switch 2, and the one going over to switch 4. It just says up, no protocol, it's there. Now we're going to jump back over to switch 2. Looking at it here in switch 2, we see that we have port channel 1 is PAgP, port channel 2 is LACP. And we jump back over here to switch 1 and show the Etherchannel summary there. It's up and good.